Good morning, ladies and gentlemen. My name is Matthew Ross and I represent Central Queensland University, Bundaberg. Today we'll be talking about pressure regulators, just basically how they work, what they are, different types of applications and so forth. So let's begin, shall we? So first, what is a pressure regulator? As the name suggests, a pressure regulator is a unit which is designed to regulate the upper pressure of a system. Pressure regulators can be set to have complete control over the regulator pressure. So this means the operator can have full control, set the output pressure to whichever they desire. Obviously different applications will involve different pressures. So regulators on important applications like gas pipelines or in factories or whatever can have built-in regulators, relief valves. My apologies. These relief valves will open and close intermittently depending on if the pressure is too high or too low, basically to keep the pressure within the limits set by the operator, which are the safe pressure limits. So why are they required? Well, pressure regulators are necessary in all systems which utilize pressured vessels. The applications of regulators vary radically. Later on we'll discuss a few of those. But basically any system which relies on pressurized vessels or containers will use regulators to maintain safe pressures. Without regulators, there is no way of regulating the output pressure to keep it within the limits of safe operating pressures. This basically goes on to what I said before in the previous slide. A regulator, the operator can have full control over the system. If the output pressure exceeds the limit set by the operator, the regulator will kick in and perform the necessary means to keep it within the limits. So let's move on. Types of pressure regulators. Well, as said before, the applications vary dramatically. They can range from scuba tank regulators to voltage regulators in electrical systems to compressed gas regulators. There's many more, however, due to time constraints, we're just going to keep it to these main three. So we're going to talk about scuba tank regulators a little bit more. Scuba tanks rely on regulators placed in the mouthpiece, and also there is one in the back of the tank on top. They reduce the pressure of the air in the tank to a safe level, but also allow for air for the diver when they need it. The pressure in the air tanks is around about 3000 psi, which exceeds the limits of safe operating pressures. So the first stage of the regulator reduces this pressure to about 140 psi. The second stage of the regulator reduces this pressure even further. The pressure it reduces it to in the second stage of the regulator is dependent upon the depth of your dive. Because this is all to do with ambient pressure, the deeper you dive, the more pressure there is on ambient pressure. So the deeper you dive, the less the air pressure in the tank has to be reduced by. Now the second stage of this regulator also supplies the air to the mouthpiece for the diver. When the purge button on the front of the mouthpiece is depressed, this forces a lever inside the actual mouthpiece to allow air to be inhaled for the diver. When the purge button is released, that lever is left alone, the valve is blocked, and we continue again. So just a few images of how the regulator works. The picture on the left shows the purge button in its natural position, its unpressed position. You can see that the lever is blocking the air from the tank, which means that there's no air allowing to go into the mouthpiece. And when we move to the picture on the right, we can see when the purge button is depressed, the lever is forced down. The port from the air tank is now open, which is now putting air into the mouthpiece for the diver to use. So that's basically the operation of a scuba tank regulator. Now, changes of designs. There's many different variations to pressure regulators. Depending upon the application, you'll use a different regulator because sometimes with more pressure, you'll need a stronger, more versatile regulator. So yeah, the variations of regulators include like diaphragm and piston sensing, and soft and hard seats. There are many different variations to pressure regulators. Some applications require a different unit to be able to handle extreme pressures or heat which they may be exposed to. More variations of regulators include diaphragm and piston sensing and soft and hard seats. We won't go into too much detail about these at all, as said before, because of time constraints, but If you wish to know more about these types of regulators, please feel free to use these links. They're very helpful. Thank you very much. And 07 Moosey Bro.